All right, let's start over. So this is an AIA accredited presentation. The agenda's up there. We'll have the recording for this. Course description is there. I think you've seen it. We're going to try and learn a lot in an hour and also have some time for questions. This is our core ideology, and one of the things that drives our goal here is that we believe that sustainability is a key part of driver in our organization. So we're going to start with what is embodied carbon. And I'm sure you've all seen this graph about global temperature change and what's forecast based on carbon emissions. So we've got a challenge. Embodied carbon is a relatively recent sort of player in the global sustainability discussion. There's been a huge focus on operational carbon ever since LEED came into the picture 20 years ago or more. And there's been a great emphasis on efficiency and reduction in emissions from operational sources. But the embodied sources were kind of left out of that picture. And actually, when we're looking at the next 25 years of construction, the embodied energy that we're putting into building new structures is about the same as the operational from the existing. So our industry is a huge piece of this, the design and construction industry. So embodied carbon is really everything associated with building construction except for the operation of the building, right? So it's everything from extracting raw materials all the way to what happens at the end of life of our work. So it covers a lot. You all are probably familiar with this as well. Scope 1, Scope 2, Scope 3 emissions. It's how organizations, institutions think about how to classify their emissions, and are they reporting Scope 1, Scope 2, Scope 3? A lot of the embodied carbon that we're talking about generally falls into Scope 3 emissions. We're not going to get too deep into that. This is a fun anecdote that somebody shared with me a few months ago. It's from the stonemasonry company, but in post-World War II France, they did sort of an embodied carbon analysis that was really based on how much coal they needed to produce a cubic meter of concrete versus a cubic meter of stone. And so that's why there's so much that's built in post-World War II France that's out of stone, also for aesthetic reasons, but to extract and cut stone was like a 20th of the energy that they would need for concrete. So a different perspective on it, and that's part of what we're talking about here today. So Thornton Tomasetti, we've been in this space for a long time, going on 12 or 13 years with embodied carbon. We're part of SE 2050, which is for the structural engineers. It's our way of providing education, advocacy, reporting, and reduction in embodied carbon. In general, building structures, the structure piece of it is probably anywhere from 50 to 70 or 80% of the carbon footprint of the building. We contributed heavily to Carbon Leadership Forum's baseline studies and SE 2050's database. We've got we're an 1,800 person firm globally. We've got about 250 members of our embodied carbon community of practice, and it's people that are just interested and passionate about the topic. So I co-led this group for about 2 years. We have various meetings monthly. We have a podcast you can look for it if you're interested in 5 to 8 minute podcasts. We've got a podcast series. So getting to the heart of embodied carbon, how do we measure it? It's brutally simple on its face, and then it gets more complicated. But essentially, it's a cost estimate where the cost is carbon, right? We find our material quantity, which we know pretty well if we've got a nice developed Revit model. If we don't have a nice developed Revit model, we're working on base studies, rough quantities, things like that. And then every every material has an embodied carbon intensity. Let's see if I can get back to Teams and let some folks in here. Letting them in. Perfect. Thank you. Every material has its own embodied carbon intensity, and then you multiply those two things together and you come up with the embodied carbon estimate. The trick is in what is embodied carbon intensity? Is it kilograms per meter cubed of concrete? Is it kilograms per cubic yard of concrete? Is it kilograms per pound of steel or per ton of steel or per board foot of timber? It's one of those comparisons that you might see if you're on LinkedIn or if you're on other social media and you see something about here's why concrete is more sustainable than steel, right? It's got less embodied carbon per ton. And then steel will say, here's why steel is more sustainable than concrete because there's less embodied carbon per cubic meter or something like that. Or maybe it's the reverse. I can never keep that straight. But you just take all that with like a heaping tablespoon of salt because it's all, any of those wild claims about this is the most sustainable material, it's just, it's not true. You can believe that. Where is the our studies and based on similar studies from SE 2050, a lot of it in the structure is in the floors. So the floors, what we do with our floor material, is it an 8-inch concrete slab? Is it a slab on metal deck? Is it a CLT deck with a 2-inch, gypcrete topping? That has an outsized impact on the carbon footprint of the building. Right, everything else plays into it: foundations, columns, shear walls, at least on the structural side. And the other thing to keep in mind is that, like I said before, the building structure is anywhere between 50 and 70 to 80% of the embodied carbon in the building. Right, the other piece is from the cladding and then the finishes and the rest of the other components in the building. We went through that first part kind of quick, so I'll stop for any questions. Is this topic somewhat familiar to everybody? Some head shake, yeah, okay. All right, we'll keep going. So concrete, DC is a pretty heavy concrete town for a variety of reasons. About half the work that I've done in my career has been on concrete structures. Look, it's economical, it's versatile, durable, it's available, it's a local material, it's constructible, and in some ways it's beautiful. And there's a reason it's like the #1 man-made building material on Earth, right? It's everywhere. When you think about concrete and the embodied carbon of concrete, just think about cement. So when you hear that there's a higher cement content, just think that means more embodied carbon, right? Portland cement makes up about, call it average 10% of the volume of a cubic yard of concrete, but it's like 95% of the embodied carbon within that yard of concrete. And the reason is that it's all in the cement manufacturing. So it's all in that, got to heat the kilns to that 2000-degree temperature. And then you're creating this chemical reaction to get the clinker and to get the cement that is off-gassing and releasing carbon dioxide as well. So there's an advantage to having cement plants that are run off of renewable sources, but it doesn't completely solve the problem. So just keep in mind, always remember that when you hear concrete, think about cement content, and that's what is really driving the embodied carbon. And this is just a way to show that as the concrete strength, the strength is on the x-axis on the bottom. As the strength of the mix goes up, the embodied carbon, which is on the y-axis, this might be in cubic meters, increases as well. Right, so those higher strength mixes, generally speaking, have more cement in them. And so they've got a higher embodied carbon content. What's interesting is lightweight concrete on the right actually has a higher carbon footprint than normal weight concrete because they've got to dry out the aggregate, goes in the kiln, so the aggregate's got to be dried out. And then there's usually a higher cement content to get the same strength versus normal weight. So that has become a really interesting debate when we're doing steel framed buildings and we're doing a slab on metal deck. You do a 4.5 on 3 normal weight concrete slab and take a little bit of a hit maybe on your steel tonnage, but you have a drastically reduced embodied carbon floor slabs versus doing, say, a 3.25 on 2 lightweight system. But we'll talk about that more later. Steel is really interesting because steel isn't a local material, right? There are a few major steel producers, and most steel production is classified either into a basic oxygen furnace, which is at the top, or an electric arc furnace. And I got these visuals from Nucor, which is really interesting. Basic oxygen furnace, you can really think about as extractive steel making, and electric arc furnace is more like circular steel making, right? So the images on the upper left are basic oxygen furnace, right? The first one is, I want to say that was early 1900s. On the right is early 1900s in Pittsburgh, and then present day in China on the left. Similar kind of smokestack and really industrial look, whereas electric arc furnace on the bottom, you don't have the smokestacks. It's a very different kind of steel production. And the reason that's important is because electric arc furnace is much more efficient. They're using a higher percentage of recycled content. So the embodied carbon of electric arc furnace steel is drastically lower. You know, 40% of the carbon footprint of basic oxygen furnace steel. So there's a lot of numbers on this screen, but I do want to kind of cover most of them. 70% of global steel is basic oxygen furnace, which is the higher embodied carbon. China is about 50% of the market, and they're 90% basic oxygen furnace. The US produces 90 million tons of steel a year, which took me actually a few days to get my head around that number, 90 million tons of steel a year, and 70% of that is electric arc furnace. So one of the things that we do when we think about steel, and if we've got a steel structure with a lot of tonnage trying to reduce the embodied carbon of that structure, is thinking about where are we getting our steel from? Is it electric arc furnace? Is it basic oxygen furnace? Are we getting it domestically? Are we getting steel from China or other sources that it might be a basic oxygen furnace? Then if we're getting our steel domestically, let's say it's from an electric arc furnace, then the differences come down to, well, what's the grid where that steel is being produced? Is it being produced using coal power, or is it on a renewable grid? The problem is that when we're designing a building and we're providing specifications, we can't just say, well, I want steel from the upper Northwest plant that is going to be half as much embodied carbon as what I could get in Alabama that's closer. That's hard to do. It's not like concrete where we can say, well, the ready mix plant that's right over here, they've got Portland lime cement, and they can reduce their Portland cement quantity and get us a lower embodied carbon mix. So the major embodied carbon difference with steel is in the production method. It's not as local. There aren't as many levers to pull, right? There's no steel mix design like there is with concrete mix design. So we've got much less control over what we're getting. So again, the focus for us as designers is being really efficient with our materials, considering high strength steel where it's appropriate. Because you can see that bullet point, high strength steel is really a very small cost add in general. But it's a 25% plus increase in efficiency.
And there's nothing different about properties of the steel based on which type of production.
I can't say for sure. I'm not a metallurgist, but is in terms of structural design, there's no difference, right? So, and in general, like all the wide flange steel that we get in the U.S., it's like 99% recycled, right? And almost all of it comes from an electric arc furnace. So you show a W18 by 35 on your drawings, it's going to be a relatively low embodied carbon compared to, oh, you spec a 14 by 900 jumbo shape that might be coming from Belgium or from China that maybe has a higher embodied carbon content. A lot of the plate material and coil shapes like HSS, right? If you have a project where everything's going to be HSS and exposed, that's going to have a higher embodied carbon content. So even in the US, we've got plenty of the basic oxygen steel, basic oxygen furnace steel that's plate shapes and other things. Yes.
Not the right time to ask a question, but what about things like rebar? Where does that come from?
Yeah, so a lot of the rebar has a high recycled content is from the US. So it's generally a lower embodied carbon than if you got it from somewhere else. So the nice thing is too, you can Google like AISC or rebar average EPDs, and you can get a lot of the EPDs for those kinds of things in general. Like steel in general might be 1,000. It's basically 1,000 kilograms per, like 1,000 kilograms per ton. Rebar, I think, isn't too far different. So as you all know, Architecture 2030, SE 2050, other organizations, CLF, Rocky Mountain Institute, have all kind of joined forces to combat this challenge and to address embodied carbon in our building structures. State and local policy has been kind of key over the last several years. CLF has a great interactive map that's continuously updated with where policy is either in the works or has been enacted to at least track. It's not always reductions. It's a lot of data collection, right? Don't quite know how much embodied carbon is in every building right now because we haven't been tracking. So once we track it, then we can look at what are the ways to reduce it and reduce it efficiently and find ways that we can reduce the embodied carbon in our buildings and make things more efficient and save money and save schedule. So there's this great trifecta that's happening, right? With when LEED first came out in operational energy, it was a sort of a sustainability driven measure, but in reality, it was a market driven measure. It was how do we make things more efficient? How do we save cost? So embodied carbon is kind of headed the same way. GSA has limitations in PBS P100. So that is more about in the procurement. But that's, and then we don't know what's coming next in our locality, right? There's always the opportunity for change. Is it Department of Buildings? Are they going to start asking for an embodied carbon takeoff as part of a permit submission? Are they going to ask for some of this data? It, could happen. I'll have to see. Take a minute for questions.
I guess it depends on how aggressive you go with requirements such as LEED, where you can sort of enforce that, right?
Yes,
Like,
that's right. Yeah.
How does it survive the PE exercise? I don't know.
It's a question every project asks, right? It's, it depends. If there's that intersection between saving cost, saving schedule, and getting the project built the right way and or lower embodied carbon, it tends to work out. right? There's got to be the economic incentive for this. We talk about it, that we can't design our way out of this problem, right? We can't just as designers go and specify the lowest embodied carbon materials and hope that it gets through the VEs and actually gets built. We also can't regulate our way out of this, right? It's going to be some combination of regulation, market forces, right? The economy has to push for this. And whether it's tenants asking for it, building owners, the public, it became a big thing about, is you're building a LEED platinum building, is you're building a LEED gold building, and tenants would pay higher rents for a LEED platinum or a LEED gold building. Is there going to be something that's similar for embodied carbon? We'll have to see.
Do you have clients that are curious with regards to buildings that exhibit a good embodied carbon approach?
Yes. The question was about having clients that I guess prioritize embodied carbon, right? So the case study at the end is the Amazon headquarters in Arlington, and that was a top priority for the project, was reducing embodied carbon. So if you have a project that's going for net zero, or maybe a passive house type project, or well certified, right? All those would have some component of embodied carbon. And so the key though is, how do we turn this discussion into what's best for the building and what's most marketable for the building versus what cost adds can we make to tick a box or to get a certification? Right? That's the challenge right now. Developers aren't in the mood to spend any extra money, and it has to make sense.
Do you have case studies with regards to a client that has this priority over the same use group, like residential, office, and this is a LEED embodied carbon building, and this is not your just typical market rate? Do you have those case studies?
I don't have them with me here today, but we are working with developers in the area that have made it a priority that for some of their new designs that they are incorporating embodied carbon requirements, and pretty sizable reductions as part of their sustainability goals for the project. And you see that some with some projects, if they go mass timber or if they go with different building materials. So I'll go through some things about how to consider embodied carbon in the design. And the real key is starting early with clear goals, right? It's like every other design intent that you all go through, because you're on the projects before most other consultants. It's what's the goal of the project? What goals does the owner have? What goals does the client have? And what is the team trying to do? And then having that collaboration between the entire design team, the sustainability consultant, and hopefully the construction manager as well, because having the contractor involved in the room early is really key, because they are providing feedback on what's in the local market, what's available, what's not available. We all see things in the news about this low embodied carbon material or that low embodied carbon material, and some of them are just in a lab somewhere where they're making 5 grams at a time. But some of it is actually, well, this is being done in New York, and oh, by the way, they're building a plant here. Okay, that's going to be available by the time our project gets off the ground. So having that discussion with the contractor is really important. The structural frame design, then you start looking at what pieces of the structural frame do we have, and what choices are we making, material wise, grid wise, what loads are we supporting, and then specs and bidding, right? What requirements can we put in the specifications that the contractor can achieve and not add cost? And then how is that bid out and how is it enforced? And then in terms of concrete, it's reviewing mixed designs. And then during construction, it's tracking things. So if you put out an embodied carbon spec that says the concrete needs to comply with this embodied carbon and the steel needs to comply with these recycled percentages, you have to track that during construction. Obviously, it's like anything else with LEED. So we can start from a baseline building. And then the choices that we make as designers during early part of design really affect where the project ends up from a carbon footprint standpoint. We can make some choices that increase the grid size or that lead to thicker slabs or lead to a different foundation system. And all that does is drive up the embodied carbon of the project. And then what usually has been happening over the last few years is sometimes projects get to like 50% PDs or permit level, and then the client decides, well, all right, we've got some embodied carbon goals. So we want to get things into the spec now to reduce the embodied carbon in the structure. So that can take that red line and drop it some. But really that's kind of swooping in at the end to try to get things back to maybe where they would have been. The better opportunity is, again, starting early with this, if it's a clear goal for the project, then you can look at what's the grid size, what slab thicknesses will we have, what materials can we look at to make good design choices. Then from there, anything you do with the specification and procurement of materials only helps. The other piece of this is setting reduction targets. I'm not going to talk through everything on the screen, but as you all may know, actually understanding what that reduction target should be is very difficult because we don't have a lot of metrics on the embodied carbon of the buildings around us, right? If anybody has a number right now in their head of what the typical embodied carbon of a DC residential building is, a multifamily building, please let me know, because I don't think anybody has that. Right? That data isn't there. We haven't been tracking it. So that's one of the goals of SE 2050 is that they've been collecting and building a database of structural projects across the country. One of the early takeaways, they did sort of a first pass at some of the data, an inaugural data analysis, is what's in the green box. That if for an overall building structure, for the structural piece, the target should really be around 270 kilograms of CO2 per meter squared of the building. You really want to make sure you're below 250. And that's just averages based on the data that we have. But there isn't that great data point that says, well, an office building should be this, residential building should be this, an arena should be that, it should be this. There's not that much clarity in the data yet. So even knowing what to reduce from is challenging, right? I think we're all in a field where if somebody gives us something to do or a target to reach or a goal to aspire to, I think we're all pretty driven enough to try to get there. We're in a situation with embodied carbon. Everybody's just saying reduce, 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 but reduce from what and to what is hard. So it makes those conversations a little bit more challenging. I alluded to this earlier that a life cycle assessment is really the key tool. And when I talk about life cycle assessment, it's a little bit different from a structural perspective, but it's looking at the building structure as a system and not just a material. So not just saying, well, steel is this, concrete is that, timber is this. It's, well, if we have a reinforced concrete office building or residential, let's call this a multifamily building, like a reinforced concrete multifamily building, what's the grid size? What's the slab thickness? What's the foundation system? Let's do a very quick study to say, here's what we expect from the embodied carbon of that building system, not material. Then, okay, do it out of steel. All right, you've got maybe a taller building. You've got more glass on the building. You've got more facade, but your foundations are different. Your grids might be different. And then if you go all the way to a mass timber building, again, very different grid system, different foundations, maybe a different size building. So all of those need to be looked at early on. And for us, that's usually a very quick study. We've got tools with, we've got some really great, very simplified design tools that we can do base studies. We can do some things in Construe, and we've got a program called Asterisk that can sort of generate a lot of this fairly quickly to look at options. And it's not going to be exact, but it's going to give you a ballpark range. So that's what you always want to look at on a building system and an overall building standpoint, not a material versus a material. And then a few of the key factors, again, from a structural standpoint in the design that affect embodied carbon. One is, can we reuse the existing structure, right? That's a big thing in DC. We've got a number of building projects that we're reusing what we can, right? Office to residential conversion, office repositionings. It's a great opportunity rather than demolishing and rebuilding new. What's the grid size? I did a study a few years ago of a 30 by 40 office grid versus a 20 by 20 office grid. And a 20 by 20 office grid has 30% less embodied carbon just off the bat than a 30 by 40. Now, nobody's running out right now to build a 20 by 20 grid for an office building, especially not in this environment, but it shows the difference in those simple early choices. It depends. What's the goal of the project? What are people trying to accomplish?
That also makes it hard to do a parking garage, which reduces operating carbon transportation.
That's right. So there are a lot of factors that go into it, but grid size is one of them. If you can shave 3 inches off your slab by going from a 30 by 45 to a 30 by 40 or a 30 by 35, it's worth looking at. And then what are the required loads? We do a lot of buildings in DC where it's just kind of assumed that our office loads are going to be 100 pounds per square foot to potentially allow a GSA tenant in the future, whereas the rest of the country uses 50 PSF plus 15. Could that be something that gets looked at in the code here, or as a general good practice? And then again, what's the structural material choice, like we just talked about? And then after that, it's being efficient with our materials. So that's something that you can, and everybody always does, pounds on the structural engineer. How do we get another inch out of this? How do we get an inch out of that? And it's usually about headroom. But if you can save an inch of slab or save some tonnage off of the steel frame, it's better for embodied carbon. It's better for cost. It's better for schedule. So there's that intersection of kind of doing the right thing that makes the most sense for the project. And then once we've got a Revit model, especially once we've got a Revit model, then it's a lot easier to track quantities and estimate what the embodied carbon of the structure is. We've got a program called Beacon that is a plugin that we developed for our structural Revit models that allows us, like, just with a couple of clicks to get a very quick estimate of the embodied carbon in the structure. And then we can iterate on, okay, now we've changed the grid, we've changed the floor slab thickness, we've added some shear walls, where are we? And let's track it and evaluate where we stand. That. Pause for any questions? All right, let's keep going. So here's some specific material reduction strategies, specific to some of the major structural materials. I'll fly through these. You all have the presentation, but concrete, remember, concrete is a local material where they can make a lot of changes locally, right? And it's a performance item. Think about concrete as a performance item. We as a structural engineer, we're specifying strength, we're specifying durability, and then it's really up to, and we may specify a couple other things, but other than that, it's a performance item. The contractor is going to work with the subcontractor, with the finishers, with the formers, with the post-tensioning subcontractor to craft the best mix for that particular application, for the weather, everything like that. So as you all know, you might have a project that's a 10-story multifamily building here, and the structural engineer might list 4 different types of concrete on the drawings, but you actually end up with 47 mix designs, right? It's because of early strip this, Aaron trained that. And so the best thing and say, this is a performance item. Here are the targets that we want to meet embodied carbon wise, and then let them do the work. But there are things that are out there. There are new materials all the time. Portland limestone cement wasn't around in our region 6 or 7 years ago, and now you almost can't get a mix without it. And that, contributes to some embodied carbon reductions. One of the things, like I mentioned earlier with concrete especially, is what's in the local market? What can the contractor get? What makes sense? What are the costs involved? Is it cost neutral? Is it beneficial to the project? I'll take 1 minute and just highlight Carbon Cure. Has anybody heard of Carbon Cure? Yeah. Okay. So Carbon Cure came up with a really great name because they're the cure for carbon, right? And the cure. The thing that I love about Carbon Cure isn't so much the amount of reduction in embodied carbon that it can do. It's basically liquefied carbon dioxide that gets added to the mix, almost like an admixture, like you would add super plasticizers or anything else into your mix. But the amazing thing about Carbon Cure is they started using Carbon Cure in mixes around in our region before anybody asked for embodied carbon reductions. The CO2 mineralizes in the concrete mix and allows a slight reduction in the amount of cement that's in the mix. And cement is expensive enough that when Carbon Cure came to the market, they were selling Carbon Cure at such a rate that the ready mix suppliers could reduce the cement in their mix and save money. And even though they were paying for Carbon Cure, it still was a win for them. So this is, again, one of those intersections of here's where some market forces and a really great technological idea contributes to lower embodied carbon and helps everybody's bottom line. So that's why I love talking about Carbon Cure. Yeah.
For technologies like this, I'm always skeptical personally, because where do they get that carbon? Where liquefying carbon is not free, right? Where did that come from? So after all of those calculations, you seem to know about this kind of a company. Is it still reducing carbon?
It is. It's waste. It's captured CO2 from like industrial processes, right? So it's similar to like fly ash or slag or other supplementary cementitious materials that go in concrete mixes. They're getting those from a steel plant or a coal plant, right? The idea is eventually our grid will be different and our processes will be different, where we won't have fly ash and we won't have slag and we may not have all this waste carbon to do this with. But in the meantime, it's a little bit like, taking lemons and making lemonade.
What does it do to the strength of the mix?
So in theory, it bumps it up a little bit. And that's why then they can back off the cement content a little bit, right? So in the end, it's not intended to have any plus or minus on the strength of the mix.
So they can do a range of strengths.
That's right. That's right. So we've seen it used on a number of projects very successfully, as far back as 2018 or so in this region, with really no complaints. So that's one example. But again, those are products like this are sort of talked about and are coming to the market all the time. So it's a matter of evaluating them and what impact do they have on strength? What impact do they have on durability? Are there aesthetic considerations? Are there finishing considerations? There's just a whole lot to think about when it comes to mixed designs. Let's fly through some of this. Steel is harder, like we talked about, because it's not a local material and there are fewer levers to pull. So with steel, our approach at TT has been, we're asking for EPDs. We want to know where we stand with the steel. We're trying to optimize tonnage. We're prioritizing domestic steel, and we're prioritizing high recycled content, which really means electric arc furnace steel. And where we can and where we need to, we're considering high strength steel to reduce shape sizes. And then timber, obviously mass timber has a lot of advantages. Not every building can be built with mass timber. The code is advancing every year in terms of how high you can build. The photo on the right is Ascent in Milwaukee, which is the tallest mass timber building in the world. And, it's a lighter structure, and, there are then debates about do you count biogenic carbon or not in those calculations. And timber has to be sourced responsibly, right? It's no free lunch here. So something to think about. Before we get to the quick case study, just conscious of time, we've got about 15 minutes left. I'll pause for other questions. All right, so this is Metropolitan Park 678, which is Amazon's second headquarters in Arlington, was completed a couple of years ago. Project started in 2018. This project was actually my introduction to embodied carbon. We were in one of the first design meetings, and the owner's representative our client really stood up and said, what are we going to do about the carbon footprint of all this concrete, right? It's 3 million square feet of concrete construction. It's 175,000 cubic yards of concrete. It's two 22-story office towers on a huge 4-level below grade parking podium. There's a mass timber event space, which is in the lower right. So there were some very clear sustainability goals from the project at the outset. And this project had Clark Construction on board very early as a construction manager. So we had an architect, a sustainability consultant. We were on board as structural, and then Clark as the construction manager. And that group really got into a room very early to determine how we were going to approach this. So this project was really the first large scale concrete embodied carbon reduction in the DC market. So we achieved a 20%, a little bit more than a 20% reduction in embodied carbon from the regional baseline. And that was mostly due to a collaborative approach between the entire team, and then an emphasis on performance specs of allowing mix designers to craft the best performing mixes that had lower embodied carbon. Anybody done a post-tension concrete building in the district? Much everybody, because that's what we do a lot of. It used to be, and I saw this all the time, we would get mixed designs, right? We spec a 5,000 PSI concrete slab, but it's post-tension, so it needs to get up to strength really quickly so they can stress the tendons and then be able to strip the formwork and do the reshores and keep going. That 5,000 PSI mix would be at 6,000 PSI in 3 days. And by the time we hit 28 days, it would be at 9,000 PSI. So I slept really well as a structural engineer because we were getting almost double the strength that we asked for, because the mixes ran hot. They would just 100% cement, no problem. Don't want to risk not being able to stress the tendons on that third day, and don't want to risk the cycle times of the floors. So this was really the first project where it was an emphasis on how do we dial that back, right? How can we reduce the cement content in our mixes to a point that everybody's still comfortable with the performance and with the schedule, but do we need 100% cement in all of our mixes, right? And the answer was no. We had a lot of cement replacement and things like the foundations, the columns, the shear walls. We had some cement replacement and the use of carbon cure in the slabs. So there was a lot of testing of mixes early on to try things out. And then a lot of adjusting, right? When in hot weather, they could do certain things and they could reduce embodied carbon in the slabs by 15, 20%. When the weather got cold, well, maybe you got 5% reduction. So it was kind of constantly adjusting all through construction. And this one, there was no impact to the schedule. This was built during COVID, but there was no impact to the concrete, to the topping out schedule of the project. Couple of photos, lots of concrete, and then our mass timber event space too. And I'll highlight sort of the approach that the team took that worked out really well. It all started from owner commitment and then communicating that commitment and clear goals to the team. And then the design team was really engaged. This wasn't an afterthought, or, this was taking up a little bit of time every week with thinking about it, especially as we were kind of getting our heads together on how to approach this. And then having the contractor at the table was key, because they would go away and talk to the suppliers, talk to the subs. What can they do? What makes sense? We looked at some design options for different pieces of the building. And then once we got through into design, it became performance-based specs. And then this was a very brand new topic at the time of bid. So the bid documents contain some extra information and literature about what the concrete subs could expect and what the requirements were, what we were looking for. The bid interviews actually included some discussion with each of the subs about how they would approach reducing the embodied carbon of the concrete, right? We only had 45 minutes or an hour with each of the subs, and we probably spent 5 or 10 minutes with each of them talking about what they could do and how they would approach this. It was at a time when none of the concrete subs in this region had data to point back to say, oh, we achieved 30% here, we achieved 10% here. That data didn't exist. So those bid interviews were really important in terms of, well, let's talk about it. How are you going to approach this? How are you going to look at the performance of those mixes and try to reduce the embodied carbon of them? And it ended up working out really well. The two selected subs, before they were even officially selected, one of them started doing early mix testing. They both saw this as an opportunity to get on the forefront of this and start establishing themselves and get that data for themselves, understand the performance of the mixes, where they could push things. And then once we got into construction, there was this effort to track the embodied carbon of the mix, or embodied carbon of the structural frame all through construction. So every week during the lead meetings that they had, part of the output was the contractor was filling in a spreadsheet of, here's how much concrete we poured this week in the different mixes. Here's the embodied carbon that is in the EPDs of the submittals that we got approved during the shop drawing review. And here's the embodied carbon that we placed every week. And so we could track it during construction. We were targeting at least a 10% reduction. We didn't know what we could get, and it turned out to be a 20% reduction. But you can see to have that kind of success on a project and to do it on budget, on schedule, it took the team starting from an early, from right out of the gate. If you just come in at the end and you're in bid time and you throw in some requirements to reduce the embodied carbon of your concrete, it's going to drive up cost. It might drive up schedule. It's just going to come out of nowhere. So having that early engagement is really key. With that, how do we really get to zero? That's a broader discussion, but it's got to be a broader decarbonization effort. It's going to involve new industries, carbon capture and storage, renewable energy, things that are going to overall be good for the markets, good for the economy. But it takes a change in how we do things, right? We're not always going to be able to go back to the same systems. There'll be a change in the future. Like I said earlier, we can't, as AEC professionals, we can't design our way out of the problem. It's too big of a problem for that. We can make the changes that we can make, and have the impact that we can. But there's a broader discussion here. Right. So thanks everybody for listening, and I'm happy to answer questions. I think we got a few minutes.
Have you done these kinds of studies on wood buildings? Like the wood buildings that we, like firms like ours, were putting up these 5/1, 5/2 kind of buildings all the time.
Yeah.
And then it's not just us, very common.
Well, yeah.
Do you have any notion of how we're doing in that range?
I mean, in general, it's probably the lower embodied carbon if you did a 7-story tension concrete building. Right? So a 5/2 type building is, the timber is probably going to be, it's going to be less, and then you're typically not putting on as thick of a, maybe as thick of a topping material as well. And it's a light building, right? It's timber, so your foundations are lighter, everything's lighter about it. So in general, it's in the right direction.
But not zero.
Not zero. Not zero. Not zero. And we're always gonna, I mean, look, we're a people that like to build. We're always gonna build stuff. We're always gonna create what's new, but some of it's gonna be repurposing what's old and turning it into something better. And the rest of it's gonna be how do we make the new things and make them better and more efficiently and faster and with lower environmental impact. How to make it more resilient, how to make it more safe, how to make it more secure. That's what I'm excited about. That's why I've been doing this almost 20 years, and that's what gets me out of bed early. Well, if there's no other questions, Daniel's got my contact information. Did everybody, is there a sign, you got a sheet or something that you can send me to get credits? And then I'm always happy to answer questions on this topic or anything else. When I meet groups like this, I always offer up if there are random questions that you want you want a structural opinion on, or you're thinking about something, embodied carbon, send it my way. So thanks for having me, and it was really nice seeing you all.
Thank you.
Thank you.
Thank you. Thank you. Thank you.
I'm just gonna get with Pam from the MA. One sheet that we're actually intended. That wasn't, I'm just gonna get, then once I get that, would be by the end of the day, I think. Send you, didn't tell you. Yeah,
That's great.
everyone's email.
Yeah, I'll give it to my skater. That's perfect. I think, enter them in the system, whatever system.